In this video, I want to talk about how Agile Requirements Designer can be used to specify in detail the behavior of systems and features. We'll focus quite a lot of the time on test data, but in general, ARD allows you to articulate a requirement in terms that a user would understand. So what I want to do in this video is to walk through a simple process you can use perhaps to manage your flow from early investigations of requirements through to creating more formal tests of the delivered system. So what I'll do in this video is I'll talk about how ARD can be used to build models and test, but more importantly to explain how your thought processes work in the context of the development lifecycle so that you can fit how you think in your projects with the way that you use the tool to capture requirements and designs and generate tests. Now, in the previous video, I explained how the new model for testing sets out a thought process for what I called exploration, modeling and testing. Now, we're going to use that framework to introduce a simple process for using ARD in your projects. So I'll go through this in a step-by-step way, and it aligns precisely with how I explain the new model, but it becomes a bit more practical in this explanation. Now, the idea of the process is it's not something to be followed slavishly, it's a guideline. So it's there to help you fit the way you think in your projects to how you use the tool, to make this connection, if you like, and to also give you a sense of control over the process as well. Quite often when we're in our projects, we get into perhaps conflict situations where the developers and the users and the testers all have a different perspective and perhaps think they are in a different situation. Their thinking might actually be different. Their understanding of where the project actually is might differ. So the process and the new model for testing can help you to understand where you are in your thinking. And it might be different from the developers who think it's all done and dusted, the users who have concerns that things aren't going in the right directions, and the tester who thinks, well, wait a minute, something's wrong here. These requirements don't match what's actually being built. So it's sometimes helpful to step back and look at the process from your own point of view and say, well, where am I in my thinking here? Is it different from the users, from the developers, whoever? So we'll look at the process in stages. Now, the new model has these four broad stages of inquiring, modeling, informing and applying, with feedback loops from each one. I've omitted the feedback loops. They're part and parcel of the whole process, but just to simplify the thinking of how we put this process together, I've kind of omitted them from the picture. Now, each stage has some specific activities, and I want to explore these in a practical way as to what actually is going on in your project and also in your head, if you like. Modelling depends entirely on sources of knowledge, which you explore and assimilate to construct mental models, your understanding, if you like. And this understanding, these models, inform your test design. I'm going to focus on the first three of these. Applying the testing, running tests obviously is critical. It's the whole purpose of testing, if you like. But it's not relevant to how you think in terms of the modelling activity, and it's the modelling activity I want to get you thinking about. So here's the four stages, and what I'm going to do is I'm just going to highlight some of the key activities in each of the stages. Now, ARD supports, if you like, the inquiring, modelling and informing stages. I'm not going to talk too much about test data, although clearly test data is critical to the process, and CA's Test Data Manager tool can help you significantly to manage, manipulate, generate, find and so on test data to support the test preparation process, if you like. Now, the applying phase, of course, is critical, but it's not so relevant to the thinking earlier on and the modelling and the use of ARD. So I'm not going to dwell on that for very long. So the first stage is inquiring, where we select our sources of knowledge to inform our model making and obviously the testing. Now, the source of knowledge can be all manner of things. There's a diversity of sources. It could be documents, so specifications, design standards, heuristics, conventions, all manner of things. clearly, the members of our team, they are a source of information, in particular the users who give us the direction as to where the software should take, the system should go. If we have the old system, it can act often as an oracle for behaviour of the new system. So the old system is a source of knowledge, of course it is. And when the new system arrives, whether it arrives feature by feature or as a whole integrated system, the new system obviously informs our understanding, and clearly that's the actuality of the deliverable. It may or may not match the requirement, but we can use the new system to help us understand how the system is actually used and how it processes data behind the scenes. Now, underpinning all this, we still have, as human beings, our own knowledge, experience, and our prejudices and biases. We have to be careful with all these sources of information. All our sources are human created almost. They are all fallible. So we need to decide which sources are trustworthy. We need to decide who arbitrates between sources that are in conflict, or where there are gaps or there are overlaps, and so on and so forth. We have to make choices as to what we actually represent in our model. So this is a critical skill of testing and analysis in general, in that we need to understand the validity of our sources and how to assimilate this melange of information into a model that has meaning for our stakeholders, developers, and other people in the project. Now, when we create our models, we have to take the model from a certain perspective. So we might be looking at from the requirements perspective, from the end user, or we might be looking at the as-built system, the actual mechanics of how users actually get data into the system and how that data is processed. Certainly we could spend time looking at the user interface and the flow of control through GUI screens, for example, and the combinations of data give us the scenarios of interest. But another angle would be the back-end data processing. So the services that sit behind our user interfaces might be what we want to model because they are of most concern. And then again, we might actually take the view of the system as a whole, from a user's journey, an end-to-end process where we're using several aspects of the system in an integrated manner, end-to-end, to evaluate whether the services, the screens, all the features hang together as an integrated set of components. So these different perspectives, we need to have a clear understanding of how we're going to proceed with our modelling at this stage. There are two general categories or model types, if you like. Some models model the flow of control, and so they actually reflect how the user exercises the use of the system, or perhaps it reflects the processing flow through the back end of a system, the services aspect of the whole system, if you like. But other models, we take the view that actually the sequence of events doesn't matter. It's just the permutations and combinations of data that is of interest to us. So it could be that the order of inputs just simply isn't material. It doesn't matter. So a web service, perhaps the order of inputs is insignificant because all the data appears on the server, if you like, in one batch of content. There's no sequencing of the data in that respect. So in that case, we just look at permutations and combinations, and we ignore what you might say is the user experience. We ignore the flow through the system. We just look at the permutations, combinations, treat it as a tabular set of combinations. Now, when we build the model in an Agile project, we might choose to evolve our model over time as a skeletal requirement grows and evolves over time, with more detail added in stages as features are appended, as refinements are added. But it could also be that we're given a very firm set of requirements, and that is the source of knowledge that we have to use to build our models. So whether we evolve or we build our models in one go, we have this challenge of how we deal with complexity. And certainly bigger models, we tend to satisfy this need to understand the complexity by modularizing the models, splitting them into parent processes and sub-processes. And maybe there's more than two levels. Maybe there are several levels in a hierarchy of processes in order to break up a very complex model into something that's much more understandable and manageable. Now, model making, although it's done by an individual, is actually a collaborative process. We are totally dependent on collaboration with other people. And the model supports collaboration because it allows us to capture information in one place and share it, but also allows us to feed back, to demonstrate paths through a model, to show situations or scenarios that stakeholders may not have thought about. Now, the model also provides us with a fantastic opportunity to identify tests, paths, examples, call them what you like, that show a requirement is problematic. So it might be obvious to us from the analysis or the testing point of view that there's a gap in the requirement. So we can create a path that has a non-meaningful outcome, if you like. It might be that there are ambiguities in the requirement, and we can demonstrate different examples having the same outcome, or the same examples having different outcomes using the model. So we can use the model as the basis for conversations about problematic requirements. Now, in forming, in this stage, we're really looking as to how we take the model and use that as the basis of a meaningful set of tests. The model clearly allows us to generate paths through the model using the optimizer. So the optimizer tool is a fantastic capability to have a systematic way of generating meaningful paths through our models. Now, each optimization you could also call a coverage target or a coverage formula, if you like. We can look at covering a set of all nodes in the model, or we can take it to the extreme, which is all possible paths. Now, the choice of optimization is kind of subjective. There's no formula which tells me that this optimization is better value for money than that one. And it's clear that some coverage targets, some optimizations include all the paths generated by a less stringent optimization. So one coverage target might be stronger than another, but there's no guarantee it's a better set of tests. There's no guarantee that you get better value for money. It's part of the collaboration that we need to conduct to share our models and our optimizations with our stakeholders and ask them, does this give you a sense of confidence if all these tests are run and pass? Now, quite often the optimizations you embark on generate a covering set of paths, but it might be there are particular areas of the model where you have great sensitivity, where there is a real concern that if this goes wrong, we have a real problem. So it might be that you enhance your generated tests with some manually created tests. And we might add paths to our model to exercise specific or extreme or weird scenarios that stakeholders are interested in. When we specify our test values, it could be that a test case specifies a logical rather than a piece of literal data. So by logical, what I mean is the decision might be the system accepts a valid email address and rejects invalid email addresses. Well, a logical test value would be a valid email address rather than an actual email address. Or the check might be for a number has to be between 1 and 100. So we don't know what that number is. That would be a literal. The logical requirement is a number in that range. Now, quite often we need to reference data in databases, and Agile Requirements Designer has an interface to Test Data Manager, features which allow you to find or make data sourced from your databases or other sources. So I'm not going to talk too much about reference data in these talks, but be aware that these tools exist and are available to you from CA. Now, once you've got your environment prepared, you have your test cases in place, all your data's aligned with the goals of your testing, you can run your test. Now, the outcome of the tests, at least the first time you run them, could expose a failure in the system. Now, these failures need diagnosis and perhaps fixing and so on, and you may need to rerun tests, and the usual process follows there. But you might decide that actually when you get the evidence of the actual tests that something in the requirement or your model or the design of the system is kind of wrong. So you might have to go back to the users and ask questions that kind of cause some concern. Like we made a mistake, a month ago when we decided this was the requirement and this was the model and these were the valid paths. It could be that you have to go back and refine the model in some way to align with a better requirement, or for the model to align better with the requirement. At any rate, the primary goal of modeling early in projects, whether in an agile team or in a waterfall or structured environment, is to flush out anomalies in requirements before you commit to writing code and building tests. So I really just want to remind you that the real value, the true value of modeling is to do the modeling in parallel with the thinking about requirements and design. So I've said that models provide a shared definition, and this is the major benefit of them, to allow teams to collaborate. We can use models to challenge our sources of knowledge, and this is the opportunity we have as testers because we're thinking seriously and rationally about the content of systems in a very systematic way. So models help us to explain what the system will do, and it also allows us to focus attention on areas of ambiguity or complexity or where there are gaps. These are the areas that are most likely to cause us problems later, to cause the developers to make assumptions which aren't safe, or to leave gaps in the delivered system. Now, modelling is effective at any scale. Whether you do it all in your head or use a sophisticated tool that I've talked about here, modelling is all-pervasive. It's completely scalable. How you implement your models, this is the challenge of today. Shared models become trusted requirements that the users have confidence in, developers rely upon to build their code, and for testers to articulate, to inform their tests. And models, because they are independent of the software, they can allow us to evolve our thinking in the model before we make changes to the systems in the future. So they're an essential part of the maintenance process as well. So in the next video, we'll create our first model and look more deeply into how ARD supports this whole process.